3 spacecraft were already committed to Mars when the planet disappeared. In November of 1971, the Soviet Union had 2 landers descending toward the surface. NASA had just delivered Mariner 9 into orbital approach. For the first time in history, humanity was attempting a coordinated exploration of another world. And then Mars stopped being visible. What should have been a sharply defined red planet became something else entirely. From millions of miles away, telescopes began showing a strange yellow expansion spreading across the Martian disk. Within days, every recognizable surface feature vanished. The spacecraft were still coming. But the planet they had spent years preparing for no longer existed in any usable form. What engineers had not understood yet was simple. Mars had just turned itself into the enemy. For years, mission planners treated Mars as predictable. Thin atmosphere, stable terrain maps, known landing zones, reliable orbital insertion targets. Every maneuver had been calculated around the assumption that once a spacecraft arrived, the planet itself would remain visible. That assumption died before any of the missions got there. The yellow cloud expanding across Mars was not a regional weather disturbance. It was dust. Not local dust. Global dust. Winds, moving at hurricane scale, had lifted fine, iron-rich particles high into the atmosphere, creating a storm system so massive it began swallowing the entire planet. Within a short time, Mars became a featureless orange sphere floating in black space. No canyons. No impact basins. No polar caps. Nothing. The entire visible surface had been erased. And this was happening while 3 spacecraft were already locked into arrival trajectories they could no longer change. That was the first real danger. Not mechanical failure. Not communication delay. Blind navigation. Every mission plan depended on knowing what Mars looked like during arrival. Surface contrast helped confirm orientation. Atmospheric readings helped predict descent behavior. Landing coordinates depended on visual confirmation of terrain features measured years earlier. Suddenly, all of it was gone. And the spacecraft kept moving. The Soviet Union faced the first irreversible decision. Mars 2 and Mars 3 were carrying descent vehicles designed to enter the atmosphere and land on the surface. Their entire operation relied on atmospheric models built around relatively calm conditions. But now, Mars had transformed into a planet-wide turbulence system. Dust suspended high in the atmosphere changes density. Density changes descent speed. Descent speed changes survival. Yet aborting was impossible. The spacecraft had already crossed the point where mission control could stop the landing sequence. Mars 2 descended first. Its parachute deployment sequence began exactly as planned. Then communication ended permanently. The lander crashed. The atmosphere it had been designed to survive no longer matched the atmosphere waiting below. But the worst pressure had shifted somewhere else. NASA was now arriving with Mariner 9. And unlike the Soviet landers, Mariner 9 carried something far more valuable: time. The spacecraft successfully entered orbit on November 14th. But when cameras turned toward Mars, engineers saw something impossible. Nothing. No recognizable planet. Just an orange globe completely wrapped in dust. The first American orbital survey of Mars had become useless before it even began. Mariner 9 had been sent to map the planet. There was no planet left to map. And suddenly, a new problem appeared. Fuel. Orbital spacecraft survive on tiny reserves of maneuvering propellant. Every correction burn matters. Every delay consumes limited resources. Mission planners now faced a brutal choice. Begin orbital mapping immediately and waste the mission photographing dust. Or wait. Waiting meant consuming fuel while doing absolutely nothing. And nobody knew how long the storm would last. Hours. Days. Weeks. Every day Mars remained hidden, mission success became mathematically less likely. This was no longer a science problem. It was a shrinking survival window. Then the storm got worse. Dust particles had risen nearly 20 miles above the surface. Solar heating trapped additional atmospheric energy. Higher temperatures accelerated circulation. The storm was feeding itself. An entire planet had entered a self-sustaining atmospheric loop powerful enough to rewrite every mission assumption humans had built about Mars. And suddenly, this event became larger than 3 spacecraft. It exposed a dangerous truth about deep space exploration itself. Mission planning assumed environmental stability. But planetary environments were not stable. Not even remotely. Engineers had spent years building hardware that could survive vacuum, radiation, launch vibration, navigation stress, and re-entry heat. But none of it mattered if the destination itself became unreadable. The planet had removed the single thing every spacecraft required: information. No visibility meant no safe landing. No mapping. No surface reference. No operational control. Mars itself had become a system-wide failure point. Weeks passed. Mariner 9 continued conserving fuel while orbiting blindly through the orange haze. Controllers waited for any sign the atmosphere was clearing. And then something changed. The orange sphere began thinning. At first, only faint shadows emerged beneath the dust. Then dark shapes became visible. Not valleys. Not craters. Something stranger. Massive peaks rising directly upward through the storm layer itself. Olympus Mons. Ancient volcanoes towering nearly 16 miles high had punched above the suspended dust cloud, becoming the first visible objects on Mars after weeks of total atmospheric blindness. The same featureless orange sphere had changed meaning again. At first, it represented weather. Now it revealed scale. The storm had grown so deep that only the tallest mountains on another planet could escape it. Mariner 9 survived long enough to begin mapping operations. The mission recovered. The Soviet landers did not. But the deeper consequence stayed behind. Until 1971, deep space engineers believed mission success depended on spacecraft reliability. Mars proved something far more dangerous. Sometimes the spacecraft works perfectly, and the planet fails instead. That orange sphere floating in darkness was not just a storm. It was the moment humanity learned a world can erase itself. And take your mission with it. Sometimes the destination breaks first.